Okay, John Dennis, I listened to it, and I looked at your solution. I think what's happened is you can do it with the characteristic polynomial way, but you've made an error in this particular bit here. This one seems okay, and because with this first one here, 0 plus 0, so it can really, you shouldn't say 0, 0. And you know that when you have 0x plus 0y equals 0, that means x can be any number and y can be any number. And so this equation won't help you find the eigenvector. So you have to go to the other scenario. So this is not 0, 0. This eigenvector, so this eigenvector here is not 0, 0. It's actually going to be x can be anything, y can be anything. There's not 0, 0, because it can be any number and it's going to be true. So that's a problem, which also transferred over to this one. So when you let lambda be -2, okay, so if lambda is -2, and if I go to the characteristic polynomial up here, I know I get -4 plus 2 and 0 and 3 and and 0. Oh, right, okay, sorry. So then I know if I go through here, I get -2, 0, 0, 3, 0. And if I multiply by xy, I get 0. And so you know that -2x plus 0y equals 0, or a 3x plus 0y is 0. Now, this means that y can be any number, right? And it's going to be true. So as you did, you went -2x is equal to 0, and so x equals 0. X has to be 0, and y can be any number. If to be a vector though, I'm not going to make it 0. So I could make this 2, 4, and -4, any number I want, and it's going to be true. But what we also know about this is that if this is any number like 401, it's still a scalar multiple of the base vector if we just simply call it 1. And so that's why we can have this vector, because we know x has to be 0 and y can be any number we want at all. And so we do get the 0, 1, which is, I believe, the appropriate vector that we can see here. I hope that helps. Let me know if it doesn't.